Assalamu alaikum, respected teachers and friends. Today we're excited to share our project on modeling the real world pandemic data. Our work focuses on the logistic growth model, which is a powerful mathematical tool perfect for describing these kind of situations. Here, the parameters K, R, and T not basically describe the characteristics of the growth of the COVID-19 virus. It shows the approximate growth rate, the maximum carrying capacity, and much more. To bring this theory into life, we have created an application in MATLAB. Now I'm going to demonstrate how this application works. For the user's convenience, we have also included a light and dark mode in the application. Now I'm going to upload a dataset into the application. For this demonstration, I'm going to use our world in dataset. Now I'm going to wait for the dataset to be uploaded. Okay, now that it has been uploaded, I'm going to choose a country. For this demonstration, I'm going to choose Bangladesh. Now I'm going to select the auto fit mode, and here you can see a comprehensive analysis of the data of the COVID-19 pandemic in Bangladesh, and here's also a good estimation of the parameters. Now this whole thing works when the user clicks the upload data button. So it's important to understand how that works. This upload data function is basically handled by a try and catch method. When the user tries to upload a file, the function checks if the file format is supported, like CSV or Excel. If it is not supported, then the function throws an error. When the user uploads supported file format, then the next function tries to extract the data from the dataset. The problem is in different datasets, the variable names can be different, like region, countries, or etc. So this function tries to smartly handle that and extract the data as neatly as possible. That's it from me. Now I'm going to pass over to my friend.
Thank you, Shashwat. So, we have the data now. How do we find the best numbers K, R, and T naught that fits our logistic model? For this reason, we use a very powerful mathematical tool called Levenberg-Marquardt algorithm, which is actually inside the MATLAB's lsqcurvefit function. This is the formula it uses. It looks complex, but it is just a recipe for taking smart steps to find the best answer. What is P here? P is just a list of parameters we are trying to find. K, R, and T naught. J is the Jacobian matrix. R is the residuals. This is the error or the difference between our model's prediction and the real data for each day. And lambda is the damping parameter that makes our algorithm so much effective. So this algorithm uses all this information to get closer to our best answer with every step. To make sure this works very well, we need to follow 3 steps. Let's go. First, we need to give a solver the starting point. The performance of the solver is very dependent on its initial guess. A good guess helps it to find the correct answer in a faster way and avoids getting stuck on a wrong solution. So in our code, we develop a very smart method based on the data itself. Firstly, the total number of cases, K. We guess it to be the 1.5 times of the current max value because we know that the carrying capacity will be greater than current max. Secondly, the speed of the spread, we use 0.1 as a starting value. This represents a moderate growth speed that works well for the most datasets. And T naught, the day of fastest growth, we guess it to be the middle of the time period. So next. Second, we set some safety rules. We know some numbers are physically impossible, like a negative rate of speed. And this not only improves the efficiency, but also ensure realistic results and a faster search. The last instruction is the go command. We use our sqcurvefit function and we provided our logistic model, initial params we found on step 1, and the real life data, and upper and lower bounds we found on step 2, and some display options. And then it runs the algorithm to find the best fit numbers. Let us go to our live demo and see it. So welcome to our MATLAB app. We are now on country 2 analysis tab. Let's say we want to see logistic growth model for a country named Pakistan. We'll be clicking and the real life plots will be available immediately. And whenever you will be clicking this auto fit mode options, the best fitted model will be available here. And the parameters you can see at the down here. Not only that, you can also adjust the slider as per your needs, and the graph will adjust according to that. Isn't that amazing? And if you click auto fit mode again, it will again adjust the best fitted model. Now, here you will find another option called comparison analysis. What does it do? Well, it shows the comparison between the country 1, for example, Bangladesh, and country 2, Pakistan, thoroughly, along with their parameters and the comparison between the parameters. So, what does this signify? So, our comparison tab actually identifies some key important facts, like the K ratio is says to be 1.3, which means in Bangladesh, the total predicted cases is 30% larger than the Pakistan. And again, the peak on the wave. It can be seen that the peak of the wave was achieved in Pakistan 50 days earlier than Bangladesh. Not only that, but these all data can actually help in public health sector, in economic planning, or having international aid in urgent situations. This shows our app turns numerical method into real actionable information. Now, for further explanation and validating the results, I will hand it over to my next groupmate. Thank you everyone for having me.
Thank you, Cindy. I'll take it from here. So, as Cindy said, the curvefit function has done its job and given us the best fit parameters. But a question arises, how good this fit is? Just because we have a plot doesn't mean it is the right one. Now we will try to validate our numerical solution. This is where the visual dashboard of our app comes in. Here we have plotted 4 graphs for each of the country. All these plots are generated by a single powerful function called plot model results, which runs right after the model is fitted. In the MATLAB code, here we can see the function working. Let's get back to the plot. In the first graph, we only have plotted the raw data. But to see how well our model matches the data, we have plotted the logistic growth and the raw data together in the second graph. Let's have a look at the code. This part of the code plots the actual data as blue circle and our fitted model as a pink line, right on top of each other. The close alignment here gives us our first confirmation that the fit is good. But for a proper numerical validation, we need to look at the errors. This is done by analyzing the residuals. The residuals are the difference between the actual data and the model's prediction each day. What we want to see is a random pattern of dot around the zero line, for which we have added the function y line. We'll see that in the code. If we saw a real U shape or any obvious pattern in the plot, it would tell us that our model might be missing something. Here we can see the residuals graph. The graph is exactly the same what we wish to see. This plot is our most important tool for checking the quality of our fit. Here we are looking at the code that executes the plot of the residuals. Finally, after doing all this analysis, we need a way to save and share our work. For this, we have added a feature to export a professional PDF report. This is the button that generates the PDF. The code for this is in the generate PDF report push button function. The key command here is the export graphics.
Here we can see the export graphics command. This command takes all the plots we have generated, arranges them neatly on a temporary figure, and saves them as a high quality vector based PDF file. This makes it very easy to share our findings. And here is the generate PDF report button post functions. So, if I click the generate PDF report button, it will execute the code and create a complete report of our analysis. Here we have the report for the second country on our dashboard. Now, to discuss some more advanced predictive features and limitations of our model, I will hand over to Iftekhar Islam.
I'm Iftekhari Islam and I will be explaining the rest of the project Advanced Analytics. To go with this section, we have a drop down box having the first option country dashboard. After selecting a country and doing run analysis, we can see the plots where growth rate indicates how fast the number of cases increases over the outbreak, and k parameter sensitivity means how changing the value of k affects the shape and behavior of the logistic curve. In the second, we have world dashboard. This is same as the country dashboard where it shows data for the whole world. Here, RMSE indicates the average size of the errors between the model's prediction and the actual COVID-19 cases. And R2 is how much of the real data the model captures. Of course, getters R2 means better fitted. In third, we have date statistics. It takes date as input and shows total infected and total death number. Here, after selecting date statistics and inserting a date like and doing run analysis, we can see the total number of infected person and death. In the code, this show date state function does it work, where this part reads input, this part converts time, and this part catches the thing if the conversion failed. In third, we have compare countries section where we can compare between two countries like this. After selecting compare country, selecting a first country, selecting a second country, and doing run analysis, we can see the two curves here. We can see the logistic parameters, most fitted curve here. Of course, this is the most fitted curve, and the saturation. This is the part of the saturation. Now we have saturation date. It finds the date when cumulative cases become almost constant for the first country. Here, selecting saturation date, selecting a country, doing run analysis, we can see the date when it saturates. In the code, this function does the work where this part takes country's name, this part finds parameters, extend to future time, finds the part where k is 95%, and converts the time into date. We have a add marker button. Select a date, name it, select add marker, it will mark the date. Select another date, name it, add marker, it will mark another one, and you can remove it by this. We have done a tentative model with some limitations like it assumes single wave, it has fixed parameters, no real-time adaptability, it assumes accurate data. To overcome this limitation, we can use multi-wave models, incorporate external factors, switching to epidemical models like SIR, agent-based models, doing hybrid models like machine learning techniques. Incorporating these models and factors will lead to more accurate and realistic predictions. Thank you very much for your time and attention. We would be happy to answer any question or hear your thoughts.